So, so in the non-supervised clustering, in the non-supervised learning, the most important thing is the clustering over there, where you it's a part of the machine learning, and also it's the unsupervised learning over there, and it is a like natural grouping of the things over there. So as I told you that, so how many levels of learning are there? According to the machine learning, how many kind of learning? As I give you the hierarchy, can anyone tell me? At the top is what? So let's suppose top is data mining. Okay, so in the data mining we have inside we have a AI, artificial intelligence. Okay, and inside that artificial intelligence, what we have it?
Learning,
Machine learning. Okay, and inside machine learning we have
deep learning.
Deep learning. We have a deep learning. Okay, so an example of deep learning means like the algorithms of the deep learning are specifically neural network, genetic network, neural networks. Okay. So please keep this in your mind so that you have an idea that what is going in the world, because nowadays people are talking about AI, but they don't even understand what is an AI. Okay, so AI is under the data mining, and the AI, after the AI more classification is a machine learning, and then in machine learning is a deep learning. And what is a deep learning? Is the neural network basically, right? And neural network is working same like the human mind over there. That they are like copying the human mind, that and see that how human minds are working, right? So please keep this in your mind to have a more focus on it. So employees unsupervised learning. Why it is unsupervised? Because here you don't know the output of the output of the clusters. Maybe sometime you receive 2 clusters, 3 clusters, or n number of clusters. Learns the cluster of things from the past data. Okay, then assign the new instances over there. So they learns from the past cluster how many clusters were in the past, and then they keep learning to give some new clusters over there with respect to the distances. As I told you, the distances can be Euclidean distance or it can be a Manhattan distance over there. There is not an output variable, okay, also known as a segmentation. So this is also called segmentation. In marketing, if you have any course in marketing, so this word is most popular, the segmentation over there. So they have like segmentation is the most important thing over there, right? So like usually the marketing people, they want to know the segment for marketing. Where should I market? Should I market in a Dammam? Should I market in Riyadh or Jeddah? Where is my segment? Okay. So most of the marketing specialists, they are looking for the cluster. So what is a cluster? Cluster is a segment basically in marketing terminology. Okay, clustering result may be used to where it can be used for identify natural grouping of customers, identify rules for assigning new cases to classes for targeting diagnostic purposes, provide characterizations, definitions, labeling, and populations. Decrease the size and complexity of problems for other data minings as well. It can be used for outliers, okay? For example, in specific domain like rare event detections over there, or in fraud detections over there in the banks. Or so the outliers, it gives you the outlier. For example, if you have 3 cluster and one point is outside the 3 cluster and it doesn't fits into any cluster, so it means this is the outlier. So cluster analysis of data mining, cluster results may be used to, like for example, in the different things over there, right? So analysis method, what is analysis method? So the most important thing is the K-mean over there. The K-mean is very important one. I use this one in like maybe 10 years ago, I used the K-means, okay, in one of my paper, a research article. I will share that article with you. You can, if you want, so you can read it and understand how we can use the K-mean over there. You can use the K-mode. So you know about the modes. Mode is the what you call the remainder of a divisions over there. So it includes both hierarchical and non-hierarchical methods over there. a neural network. You can use the neural network as well. As I told you, adaptive resonance theory, ART. You can use the adaptive resonance theory. You can use the SOM. SOM means self-organizational map over there. Fuzzy logic. Fuzzy logic is also part of a deep learning over there. Fuzzy logic, fuzzy C means over there. Fuzzy logic is not about 0 and 1. It is in between the 0 and 1. So in between the 0 and 1, we call as a fuzzy logic. Logic means when your results are like based on points 0, 0.1, 0.2, 0.3, and there is not a discrete result. Okay, so this is used by the one which is used by the fuzzy logic. And who invented the fuzzy logic? There was a Muslim scientist. He invented the fuzzy logic. He was based in US. His name was Lutfi Zada. Lutfi Zada was one of the scientists, and he worked on that one. Okay, and he worked on it, and he I think he died recently. I think 2 or 3 years ago he died, and he was the one who invented the fuzzy logic. You can search his name and you will find that how he invented the fuzzy logic. And nowadays fuzzy logic is used everywhere. And then we have a genetic algorithm. Genetic algorithm is based on the human genes over there. Since human genes are very complex, like our DNA. Okay, you say our DNA is more complex. It has a different structure. Every person has a different DNA and RNA. Okay, do you know about what is the DNA and RNA stands for? DNA stands for anyone? General knowledge question. DNA, D-ribonucleic acid. So it is called D-ribonucleic acid, and RNA means ribonucleic acids over there. Okay, so these are the two different. From these, the genetic algorithms has been derived. Okay, so the scientists look at the complex structures made by Allah Subhanahu wa Taala, and then they see that how they are complex, what they are doing over there. So from that one, they derive some of the algorithms over there, and then they made algorithms from that. So these are the like important things over there, why these genetic algorithms came into being. And nowadays like it's mostly used in advanced AI learnings over there. So these fuzzy logic and the genetic algorithm, these are the best candidates for logics over there. How many clusters usually we have it? There is not a truly optimal way to calculate it. Okay. Heuristics are often used over there. People are thinking. Heuristics means when you put your ideas, your thinking, that is called heuristics. Like doctors look at your symptoms, okay, and then decide according to his experiences. Okay, so experiences is referred to heuristics. Most cluster analysis method involve the use of distance measure. So as I told you that clustering, they use the two kind of specifically, there can be many, but usually they're using the Manhattan distance and as well as Euclidean distance to calculate the closeness between the pairs of items. Okay. So see over there, there are like a Euclidean versus Manhattan distance, and another one, the rectangular distance. If your data is 3D, so you can use the rectangular distance as well. This is the example of k-mean, that how the k-means work. Okay, just look at this algorithm, okay, and let me know that what are the steps in it. Okay, these are very simple steps. If you know already the algorithms, okay, how the algorithm works. Algorithm is a program, but in a simple English language over there, that how normally people can understand over there. Please, I give you 2 minutes. Please look at this one, and then we're going to discuss that what is this k-mean algorithm. Okay, did anyone get the idea? Okay, if you don't understand this one, look at this steps over there, that how these are working. These are three steps of k-mean. Okay, I just give you, if you don't understand, I can give you a hint. Okay, if these are the different points, see, you have like many points. It means like even it is like not countable. Okay, so if these are the different points over there, let's suppose these are 200 points, let's suppose. Okay, so to find the cluster in these 200 points, obviously we cannot see where is the where which point is more close to which one. Okay, so what we do, we put normally, for example, let's suppose 5 points. Let's suppose 1, 2, 3, 4, and 5. Okay, so what we do it, we choose randomly 5 points. Okay, so if you come back, so say randomly generate k random points. See, so we randomly generate how much k. So k means like 5, right? So determine the value of the k, right? So step 0, so randomly generate k point as the initial cluster points over there, right? So we do this one. So what are the points you see over here? See, so this is the first. Let's have 1, 2, 3, 4, and 5. So we have 5 points. Okay. Now we will measure the every point with the center of this cluster. See, this is the, for example, mean. This we call as the mean of the cluster, or the center of a cluster over there. Okay, and this is not the fixed one. These points are not fixed one. It can move. Okay, according to the mean of that. So they will find the mean and then come to the center over there, just like this one. Now we will see that how many clusters we can easily find with that one. So the close point with that one, so we will measure every point with every one. For example, this point, we will measure the distance between the center of this point and this point, the center of this point and that one, center of this one and that one, and so we will see that the minimum distance is with these two. Okay, so this point will be in the cluster of this centroid we call it. Okay, now we will see this point. Okay, so the distance between this point and the center of centroid, this point and centroid, this point and centroid, this point and centroid, and all. So we will find the distances between all, and at the end we will find that the distance between this point and this centroid is the minimum one. Okay, so we will circle this into this cluster, right? And for example, this point will be in this cluster. Okay, this point will be in this cluster, and this point will be in this cluster, right? So now we have now one point. For example, one is centroid and one is another point. Now see, and then we will keep growing. Then we will find this point with all the centers, and we will find that this point is near to this cluster, right? And again we will then go for this point. So the cluster is becoming more and more over there. See, right? So now, so according to this one, see, so they have like a, this cluster is formed over there. Now, and we will also keep going on, and this will keep growing. Okay, keep growing, and you will see that this pink point, pink is, I think it's pink or brinjal, which color? Yeah, pink color. So this will be another cluster over there. Now this centroid will find all the closest, and even there is a difference of points you see over here. Some are very close to each other, right? But this blue is more closer to this centroid. Okay, so the blue will be with the blue, and with the, while this centroid, this one, the red will be are more closer to that one. Okay, so sometimes there is a very thin border line, see over here. So the distance might be with the points 0.001, 0.002. Okay, so when the difference is 0.001, so if, like for example, if it is more closer in 0.001, it will go to this centroid. If the point is more closer to this one, it will go to the blue one. Okay, so here we find that we are having 5 different clusters over there according to the points over there, right? it might be the case if there is any point here, let's suppose. Okay, so any point here, so we can count as a what do you call it, as a outlier. Okay, so this point is an outlier, so it doesn't fit here or there or anywhere over there. So these points can be as an outlier. Usually it can be fit over here, but if the distance is more than like the average distances over there, then we call as an outlier. And this can be a fraudulent case, or it can be a customer which is not loyal to the any of the company over there. So by this way you can find the clusters over there. So all depends on the distances. What is the distances over there? So now if you look at this algorithm, I hope that you will understand this algorithm more easily. So who can just have a look at this algorithm and give you your random ideas?
Doctor, I have a question.
Yes.
The points, it's we know the points of the nearest
Yeah,
group.
nearest point, exactly. Yeah.
Oh, okay.
Yeah, so the more nearest, it will be under the cluster. So, right? So
Yeah.
you have to choose a random 5 points, 6 points. So it depends on you, and then you need to measure it. Okay, just like you measure with a ruler or something. See, you have like any measurements thing, so you can measure with that. Okay. So now, can you explain this algorithm?
First, we have two random points.
Mm-hmm.
Then into 5 or 4 points. Okay. Then we assign the points with the nearest, the cluster. We separate them.
Mm-hmm.
And then we regroup them with each one.
Yeah,
Group.
so at last the convergence is met. Okay, so the most important thing is the convergence we have it. Okay, so convergence means at the end you have you get all the 4 or 5 clusters over there. So you repeat the process. So you keep repeating the process. Okay, and you keep assigning the points. See, you keep assigning the points with the cluster center. Okay, which is called centroid. See the 5 centers.